Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Chemistry Paper 1 higher tier from 2025. Question number 8 is on the topic of chemical changes. This question is about acids and alkalis. What is the formula of the ion that all alkalis contain when in solution? That would be the OH minus ion. A student planned a titration experiment to determine the concentration of a sodium hydroxide solution. This is the student's plan. Measure 25 centimeter cube of sulfuric acid of known concentration using a pipette. Add the sulfuric acid to a conical flask. Add 3 drops of universal indicator to the conical flask. Add the conical flask. Place the conical flask on a white tile. Fill a burette with sodium hydroxide solution to the 0 mark. Add sodium hydroxide solution to the conical flask and swirl the flask. Stop adding sodium hydroxide solution when there is a color change. Record the volume of sodium hydroxide solution used. Repeat steps 1 to 8 until consistent results are obtained. So suggest 2 improvements to the plan. Give 1 reason for each improvement. So from this, I can identify clearly there's 2 problems. Using universal indicator. Universal indicator gives a range of colors. What you want during titration is 1 color change, not a range of colors. And they're saying add sodium hydroxide solution, but how? You usually add it drop by drop. And there's a couple of other things that they haven't mentioned as well. So I'll go through them one at a time. So let's write down some of these. First improvement, use phenolphthalein. Indicator. That would be instead of the universal indicator. Reason. So the color change. So that the color change is sharp and not a gradual color change or a range of color changes. The second improvement, you could also, let me write it on this, use a pH probe. The reason, so that the pH probe shows a sharper endpoint. So you should be able to read it as 7 pH when it is completely neutralized. You could also add sodium hydroxide drop by drop. Near to the endpoint. Reason, the volume of sodium hydroxide used is more accurate. And you could say read the burette at eye level. The reason would be the volume of sodium hydroxide used is more accurate again. You could also say that rinse the burette with the sodium hydroxide and pipette with the acid. Reason is to remove the contaminants. Figure 9 shows the burette after one titration. What is the reading on the burette in centimeter cubed? So now there's a common mistake that students make. You would actually just read it from here, 25 point, and this in the third division you would read it as 25.3, which is actually wrong, because this is the volume of sodium hydroxide that is remaining. So the volume of sodium hydroxide that was added actually started at here 50, so we need to read the top space. So that's 24.7. 24.7. In a different titration, 25 centimeter cube of 0.216 mole per dm cube sulfuric acid needed 11.25 centimeter cube of sodium hydroxide solution for neutralization. The equation for the reaction is, so 2 moles of sodium hydroxide is reacting with 1 mole of sulfuric acid to form sodium sulfate and water, 2 moles of water. So calculate the concentration of sodium hydroxide. Using the volume and the concentration of sulfuric acid, we can work out the number of moles of sulfuric acid. So moles of acid is 25 centimeter cube. We need to convert that to decimeter cube by dividing it by 1000, and then multiply the volume by the concentration 0.216. It will give you 0.00540 moles of the acid. Now, according to the mole ratio, 1 mole of acid is reacting with 2 moles of sodium hydroxide. So number of moles of NaOH will be double this. So 0.00540 times 2 will give you 0.0108 moles. Using the number of moles and the volume, we should be able to calculate the concentration. So concentration equals the number of moles, which is 0.018108. Sorry, 108 number of moles divided by the volume. Now the volume is 11.25. So I will have to convert that to decimeter cube as well by dividing by 1000. So what I can do is multiply that by 1000 divided by 11.25. That will give me 0.960. Table 4 gives information about solutions of two acids. Formula of the acid is HCl and HCN. Concentration is 0.1 and 2 mole per dm cube. Percentage of acid molecules that are ionized, 100% is HCl, 0.01% is HCN. What is the correct statement about the solution of HCl and HCN? HCl is a more concentrated and strong acid, It's not more concentrated, it's less concentrated. So it's more dilute because it's 0.1 and 2. So it's more dilute. So it has to be one of these two statements. It is a strong acid because it's completely dissociating. So it will be the third option. In table 4, the solution of HCl has a lower pH than the solution of HCN. Explain why. The reason it will have a lower pH is because it is strong acid. So HCl has a higher concentration of H plus ions. Reason, since the concentration of H plus ions equals 0.1 mole per dm cube. Now this is coming from the table. So from the table, the concentration is 0.1 and it's dissociating 100%, right? But although the concentration is 2, it's 0.01% of that is actually dissociated. So only 0.01% of the 2 mole is going to be H plus ions. So you have to mention that as well. Since the concentration of H plus ions in HCl, but in HCN, it's 0.0002 mole per dm cube. That brings us to the end of the video. Thanks for watching, and I will see you in the next question.